Hello all, welcome to Excel Academy. So today we are going to discuss with respect to one problem. So that is the problem is what, that is your x of n is equal to, that is what I can say, your alpha to the power of n for the condition that is your 0 is lesser than or equal to n, that is lesser than or equal to n minus 1, and my next one which is equal to 0, that is elsewhere, right? The question is that is 0 elsewhere, 0 that is elsewhere. This is what is the question. So this is what is the given question, and for this particular question what I have to do is, so I need to prove that, so I need to prove that what, I need to prove that your x of, I need to prove that your x of z is equal to, that is what I can say, x of z is equal to, that is 1 minus alpha to the power of n into, that is your z to the power of minus n, so that is divided by, that is 1 minus alpha z to the power of minus 1, right? So this is what is the question. So the question given is, that is your x of n is equal to alpha to the power of n for 0 lesser than or equal to n lesser than or equal to n minus 1 and 0 for elsewhere. So we are going to prove that your x of z is equal to 1 minus alpha to the power of n into z to the power of minus n, that is divided by 1 minus alpha z inverse. So now we are going to take up the problem. So for the problem, my very first thing what I have to do is, I have to what, just a second. So yes, I have to prove. So now I have to start with my formula, that is your x of z. So what is your x of z formula? So your x of z formula is equal to, that is what I can say, the summation of, that is n is equal to infinity to minus infinity to infinity, that is your x of n into z to the power of minus n, right? So now I'm going to use this formula, and what is my given x of n? My given x of n is only alpha to the power of n, this is 0, so not considering this. So now coming on to this, I have to substitute, that is summation of n is equal to, what I can say, minus infinity to, it is not minus infinity to infinity, I'll tell about that. So first I'll write, that is alpha to the power of n now into z to the power of minus n, and what is my summation now? So for my summation, you can see that here it is given something, that is 0 is, that is lesser than or equal to n, that is lesser than or equal to n minus 1, isn't it? So that means that what, that means that your summation, that is it starts from 0 to, that is your n minus 1, right? That is n is equal to 0 to n minus 1 is your summation. So 0 lies between, the n lies between 0 and n minus 1, this is the center n, you can see, right? So this lies between the 0 and n minus 1, so therefore I can write it as your n is ranging from 0 to n minus 1, right? Yes. And now this is what is the formula, and for this formula what I can say that, so I can say for this formula, now if I substitute, so I'm going to get it as, yes, just a second, yes. Correct. So now I'm going to get it as what? So I'm going to get it as, that is equal to, so you know that this formula I have already uploaded in my last video about this formula. So this formula is what? That is what I can say, 1 minus, that is alpha to the power of capital N divided by 1 minus alpha. So if I apply that formula, what I'm going to get is that what I'm going to get is, before that I'm going to take n as my power, right? So I have to take n as my power, so therefore I get it as, that is n is equal to 0 to, what I can say, the n minus 1, that is equal to, just a second, it is, yes, it is n minus 1, so that is equal to what, I can say that it is alpha z to the power of minus 1 whole to the power of n. So and then what I have to do is, so then what I have to do is, I have to just complete the substitution, right? That is, I have to use this formula now. So that is, if I use this formula, I get it as, that is 1 minus alpha into z to the power of minus 1, that is whole to the power of n, right? This is whole to the power of n, that is you are going to get it as divided by 1 minus, that is your alpha z inverse, right? I guess you got it. What did we do, right? So now what you're going to do is, so now if you, what I can say, multiply this n, so to the power of n, if you multiply to this both, so you're going to get it as, that is 1 minus alpha to the power of n, that is z to the power of minus n, which is divided by 1 minus alpha z to the power of, that is minus 1, right? So now I guess you got it how to do it. So this is what is the resultant. So you nothing, he has given the question, that is x of n is equal to what? Your x of n is equal to, that is your alpha to the power of n, for that is what, your alpha to the power of n, for that is 0 lesser than or equal to n lesser n lesser than or equal to n minus 1. And so you can see that, and so has given that, and you can see that. So for this particular, he has given some range, and what you have to do is, you're going to prove that, that is x of z is equal to 1 minus alpha to the power of n into z to the power of minus n, that is divided by 1 minus alpha z inverse. So therefore now we are going to use the formula, that is x of z formula now. So you already know this x of z formula. I have already told you in the classes of Z transformation as well as its problem, right? And here you can see that you have to substitute alpha to the power of n in the place of x of n, and for the case of alpha to the power of n, he has given some limit, that is your n is ranging from, that is what, your 0 to what I can say, the n minus 1, right? So that is what was given over here, you can already see. So here it has been given, right? This particular will tell you about that, right? So that we change the summation to n is equal to 0 to n minus 1 summation, and we just substituted alpha to the power of n over here, wherein what did we do here, we just removed the n outside and we just made it as a power like this. And then what did we do, use this particular formula right now over here, and we just multiplied this power of n to both alpha as well as z to the power of minus 1. So then just a second, so wherein we got the resultant, like this, and this is what is asked to prove, and we have proved it, right? So this is what is the one more problem which we had to do, and there are still more problems like this, right? You can see the problems like 3 into 4 by 5 to the power of n minus 2 by 3 to the power of 2n into u of n. All those problems are present, and you can make sure that you can do those problems, like it is all the same process, but you have to the question is the same, different, and according to the question you are going to solve it out, right? So we are also going to do those problems in the upcoming classes, and thank you.